Everyone, I am Aaron Lee. This is my CS441 final project, Personalized Writing Style Text Detector. According to the National Assessment of Educational Progress, the U.S. children literacy rate is dropping at an alarming rate. Many primary and high school students perform well below the basic reading and writing level, and the advent of the large language model unfortunately worsened this situation. As many teachers reported, students directly copy-paste AI responses in homework assignments. Some even learn to have AI produce writings that mimic human writing style to deceive the instructors. To address this issue and provide a possible solution, I propose a template for a personalized AI detection tool, a simple classification model that can be easily trained by teachers even with no professional knowledge in computer science and therefore can be mass deployed into the education system. Due to the scale of the project, the number of people working on it, and its expected deployment environment, I choose small passages of 150 to 250 words as input and training data, and binary labels of human or AI as output. For data collection, inspired by less is more for alignment, I handpicked all the passages and hope to improve model performance through carefully selected high-quality data. I built up my dataset by curating my own past writings, peers writing with consent, copyright-free SAT and GRE reading section paragraphs, web scrape or WordPress blogs and Reddit posts following API rules, and selecting short passages from classic literatures, such as from Conan Doyle, Dickens, of the Gutenberg database. In this manner, I collect 175 passages for the human class, then manually claimed and trimmed them into coherent standalone passages. For the AI class, I used GPT-4o to generate 175 new passages that mimic the style of each human passage, with same tone and complexity but different content. And then I manually inspected and cleaned the data to remove obvious defects or near copies. Finally, I combined everything into a balanced dataset with 350 labeled examples and split it into a training set, validation set, and test sets of 60-20-20 split. And for the method I choose to employ with my final application, I experimented with a total of 10 ways to represent the text in several model families. For evaluation, I use accuracy as the primary metric, along with precision, recall, and F1 score per class and confusion matrix on the held-out test set. I tried out three types of feature representation: word level TF-IDF, character level TF-IDF, and handcraft stylometric features. I pair them up with different types of model representation, such as logistic regression, linear SVM, decision tree, random forest, boosted tree, and linear pro on BERT. Out of all models, character level TF-IDF with a linear SVM prevailed in the end, with an accuracy of 97%. To double check, I also tested the model on the whole dataset and gained a similar result. After confirming the methods I'm going to use, I retrain the model on the whole dataset and deploy it as a simple Gradio web app. The app provides a text box where the user pastes a passage and receives a predicted label plus a rough confidence scores based on the SV event decision value. Here are two pairs of example input-output. First is an expert of my peers writing and an expert of ChatGPT's writing. It successfully classified my peers writing as human. And it successfully classified ChatGPT's writing as AI. The second pair of example is harder. It will be my own writing and Gemini trying to mimic my style of writing. Again, it successfully classified my writing as human. And I told Gemini to make me my write style. And he succeeded again. In conclusion, I created an AI text classification tool via linear SVM with character-level features, in hope of deterring AI plagiarism and enforcing basic level of literacy on students. This is merely a proof of concept that can be personalized to each student and hopefully employed into the wider education system. Thank you for listening.